Switching techniques in large networks. There might be multiple paths linking sender and receiver. Information may be switched as it travels through various communication channels. There are three typical switching techniques available for digital traffic. Circuit switching, message switching, packet switching. Circuit switching. Circuit switching is a technique that directly connects the sender and the receiver in an unbroken path. Telephone switching equipment, for example, establishes a path that connects the caller's telephone to the receiver's telephone by making a physical connection. With this type of switching technique, once a connection is established, a dedicated path exists between both ends until the connection is terminated. Routing decisions must be made when the circuit is first established, but there are no decisions made after that time. Circuit switching. Circuit switching in a network operates almost the same way as the telephone system works. A complete end-to-end path must exist before communication can take place. The computer initiating the data transfer must ask for a connection to the destination. Once the connection has been initiated and completed to the destination device, the destination device must acknowledge that it is ready and willing to carry on a transfer. Circuit switching. Example: phone network. Circuit establishment. Source creates circuit to destination. Node along the path store connection info. Nodes may reserve resources for the connection data transfer. Source sends data over the circuit. No destination address. Since nodes no path teardown/circuit disconnect. Source tears down circuit when done. After some period of data transfer, the connection is terminated. Usually with the action often at hetero stations. Circuit switching is fine for voice traffic but is inefficient for data traffic between computers, because at the dedicated path is idle during missed off T connection. Timing in circuit switching. Information: circuit establishment, transfer, circuit teardown, host 1, host 2, switch 1, switch 2, propagation delay between host 1 and switch 1, propagation delay between host 1 and host 2, transmission delay time. Circuit switching and end resources reserved for call. Dedicated resources, no sharing. Circuit like guaranteed performance. Call setup required. Circuit switching with human operator. Click to preview, 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 click to preview. Circuit switching, multiplexing. A link time division. Each circuit allocated certain time slots. Frequency division. Each circuit allocated certain frequencies. Time, frequency, time. Network resources. Example: bandwidth, divided into pieces. Numerical example: how long does it take to send a file of 640,000 bits from host A to host B over a circuit switched network? All links are 1.536 Mbps. Each link uses TDM with 24 slots/SEC. 500 ms. Establish end-to-end circuit 1,536,000/24 equals 64,640,000/64,000 equals 10 seconds. 10 plus 0.5 equals 10.5 seconds. Advantages of circuit switching: guaranteed bandwidth, predictable communication performance, not best effort delivery with no real guarantees, simple abstraction, reliable communication channel between hosts, no worries about lost or out of order packets, simple forwarding based on time slot or frequency, no need to inspect a packet header, low per packet overhead, forwarding based on time slot or frequency, no IP and TCP/UDP header on each packet. Disadvantages of circuit switching: wasted bandwidth. Bursty traffic leads to idle connection during silent period. Unable to achieve gains from statistical multiplexing. Blocked connections. Connection refused when resources are not sufficient. Unable to offer OK service to everybody. Connection setup delay. No communication until the connection is set up. Unable to avoid extra latency for small data transfers. Network state. Network nodes must store per connection information. Unable to avoid poor connection storage and state. Message switching. With message switching, there is no need to establish a dedicated path between two stations. When a station sends a message, the destination address is appended to the message. The message is then transmitted through the network, in its entirety, from node to node. Each node receives the entire message, stores it in its entirety on disk, and then transmits the message to the next node. This type of network is called a store and forward network. Message switching. A message switching node is typically a general-purpose computer. The device needs sufficient secondary storage capacity to store the incoming messages, which could be long. A time delay is introduced using this type of scheme due to store and forward time, plus the time required to find the next node in the transmission path. Message switching advantages. Channel efficiency can be greater compared to circuit-switched systems, because more devices are sharing the channel. Traffic congestion can be reduced, because messages may be temporarily stored en route. Message priorities can be established due to store and forward technique. Message broadcasting can be achieved with the use of broadcast address appended in the message. Message switching disadvantages. Message switching is not compatible with interactive applications. Store and forward devices are expensive, because they must have large disks to hold potentially long messages. Packet switching. Data is transmitted in short packets, LT 1500 bytes. Messages broken into series of packets. Each packet contains data control information, routing or control information. ADAC node along the path the packet is received, stored briefly and passed on to the next node. Advantages of packet switching over circuit switching. 1. Line utilization is greater since a packet share link over time. 2. Call never blockades and circuit switching. 3. It is possible to prioritize a packets. Packet switching. In both packet switching methods, a message is broken into small parts, called packets. Each packet is tagged with appropriate source and destination addresses. Since packets have a strictly defined maximum length, they can be stored in main memory instead of disk, therefore access delay and cost are minimized. Also, the transmission speeds between nodes are optimized with current technology. Packets are generally accepted onto the network on a first-come, first-served basis. If the network becomes overloaded, packets are delayed or discarded, dropped. Propagation delay. Do we need to receive entire packet before forwarding? Takes L/R seconds to transmit, push out, packet of L bits onto link or RBPS. Entire packet must arrive at router before it can be transmitted on next link. Store and forward delay equals 3L/R, assuming zero propagation delay. Example, L equals 640,000 bits, R equals 1.5 Mbps, delay equals 3*640,000/1.5 equals 1.28 s. 1.28 is much faster than 10.5 seconds for circuit switched routing RRRL. Types of packet switching. There are two types of packet switching: datagram service, virtual circuits. Datagrams. Each packet is treated independently, with no reference to packets that have gone before. Packets can follow different routes and arrive out of sequence. Each packet is called a datagram. Virtual circuits. Pre-planet is established before in a packets are sent. Once a is established, all the packets between a pair of communicating parties follow this amerut through the network. This node sends a control packet call at call request packet to the node. If the node is prepared to accept the connection, it sends back a control packet call at call accept packet to this node. This packet follows the amerutious ways established with call request packet. Virtual circuits. Note there is no dedicated paths in a circuit switched network as these virtual paths shared by packets belonging to different messages. A packet is still queue for output over a line. Only there is no routing decision mediated no decent datagrams. Datagrams versus virtual circuits, VCS. Datagrams. Virtual circuits. Call setup phase avoided. Call setup phase needed routing decision at each node for each packet. All packets follow the same route, no routing decision. Packets may arrive out of sequence. Packets arrive in sequence. More suited if wants to send only a few packets. More suited for data exchange for extended period of time if a part of a network becomes congested. Incoming datagrams can be routed away. More difficult to adapt to network congestion. More reliable because if a node fails, packets can be routed around it. Less reliable because a failed node would disrupt all VCS through it. The effect of packet size on transmission time. There is an important relationship between packet size and transmission time. Assume there is a virtual circuit from X to Y via nodes A, B. The message to be sent is 30 bytes and each packet contains 3 bytes of control information, header, e.g. 1 data size equals 30 bytes, total packet size equals 30 plus 3 equals 33 bytes. Bytes transmitted asterisk number of transmissions equals 33 x 3 equals 99 bytes, e.g. 2 data size equals 15 bytes, total packet size equals 15 plus 3 equals 18 bytes. Bytes transmitted asterisk number of transmissions equals 18 x 4 equals 72 bytes time, e.g. 3 data size equals 6 bytes, total packet size equals 6 plus 3 equals 9 bytes. Bytes transmitted asterisk number of transmissions equals 9x7 equals 63 bytes. Packet size, e.g. 4 data size equals 3 bytes, total packet size equals 3 plus 3 equals 6 bytes. Bytes transmitted asterisk number of transmissions equals 6x12 equals 72 bytes. The effect of packet size on transmission time.